Hello everyone and happy holidays. We are super excited to get to bring some of our project designs and collaborate with Vectric with their holiday toy shop this year. My name is Sami and I am the media manager here at Avid CNC.
My name is Cory. I work on the customer experience team.
And my name is Brian. I'm also part of the customer experience team.
Vectric wanted to do a campaign this year, really leading with Kindness Matters and helping to promote or facilitate makers with CNCs to be able to create things to give away to people who are potentially in need. And we wanted to kind of piggyback on some of those projects and that idea of makers contributing to their local community by, making things that people could find fun or useful. And so we're really excited to partner with Vectric and partner with all of you to help make this happen.
Yeah, and one way we decided to do that was that taking what resources we have is that we decided to include a couple of our own designs for toys that are able to be made on CNC machines.
We are collaborating with our local community to make some toys and get them out to kids in our community. We encourage you to take either our designs or some of Vectric's designs. We'll link to their project videos in the description below and make a few toys for kids in your neighborhood or in your community. I definitely encourage you to reach out to organizations that help facilitate distribution of toys this time of year. I'm sure they would be thrilled and excited to receive some handmade toys that just have so much love. And anyways, I guess let's go ahead and jump into talking about our project designs. And what we're excited to do is to kind of think about what lessons we can learn as CNC operators and as makers from making toys, whether it's in a production workflow or a one-off style workflow as well. So let's jump into it. All right, so let's get started into our breaking down all of the different elements that go into creating a project, the concept, the workflow, all of those types of things that you would want to consider when starting a new project. So identifying the goals for your project, identifying the limitations and the overall workflow and how all of those pieces kind of come together.
Yeah, I love really starting with goals because it gives us a direction to try to reach. And so some of the goals that we like to think about are listed here, design aesthetic, what we are wanting the toy to function as, and then also who are we wanting it to function for. And so when we talk about the design, we want to talk about the quantity. How many of these do we plan on making? How complex do we want that design to be? What kind of materials or different assembly processes are going to be needed? And then also just how functional the manufacturing process needs to be. And so if we want a really fast, really smooth functioning manufacturing process, that's going to require a little bit more upfront time in design and prototyping, where if you're trying to make fewer, potentially you can have a little bit less upfront time and you can kind of handcraft those items at the end of the process.
And so once we kind of have our goals all figured out, we get to start to look at what our limitations are that might be in the way of achieving those goals. And that may include things like what tooling do we have, the availability of material, how complex this design may be when it comes to the assembly or the actual fabrication of it, and of course that timeline. And we always got a timeline we got to work with, and that's always the fun one, kind of squeeze in there and figure out what we can achieve.
Right, and so you take all of those elements, the inspiration that you had for your concept, the design solution, engineering solutions that were dictated very much by the limitations that were in front of you. We have our concept to design they're kind of similar in considering you don't always want your limitations to be the first thing you think about when you're trying to come up with an idea. You want to kind of be really open to different solutions and different concepts. based on just things you're interested in making, including your goals, who it will serve, but then introducing the limitations and then making adjustments based on those. Then you go into crafting your prototype and adjusting the tool paths and the material selection and all of those elements, making another prototype and adjusting again, and perhaps making another prototype and adjusting again, so that you can really, really refine the workflow for your production. So this is your opportunity to help make your future self happier by creating tool paths that will create less tear out, or create tool paths that are really refined and much quicker and faster to run. So considering the setup time, the cutting time, the finishing time, all of those elements here at this point in the prototyping stage will save you a lot of heartache later. And then you want to jump into your production. So you want to make sure that you have any jigs that you might need for setup, your work holding really refined, and any kind of finishing workflows if you're going to do round over on the router table or sanding, and any kind of those finishing processes, you really are setting yourself up for success there so you can get into the groove. All right, so Brian, you made this amazing project, which I absolutely love. So give us an overview of the project, and then we can kind of dive into more of the specifics of the inspiration and the goals you were trying to accomplish.
Yeah. So when we started with this, we were kind of working with Vectric on these designs for toys and to go out. And from previous projects I worked on, one thing that kind of really grabbed my attention was just the ability for analog and really mechanical motion that don't need any batteries, nothing digital, nothing electronic. And I really wanted to try to latch onto that as good old classic toy design as it was. And so we kind of did a little bit of searching around, and one thing that kind of caught our attention was the idea of these articulating snakes that have different parts and pieces that were able to get posed in certain ways and have to be a bit more kinetic and moving as a interaction element. And it was a nice little puzzle to see how we can do this in a way that fits nicely to be manufactured on a CNC, to be scaled in certain ways, as well as to be entertaining and be functional along with it. And going through it and seeing the different methods that they use on how to get these different ways of motion that they have with different toys. So you can either do slits in there to have flexibility, and you can also do separate different connector pieces that all slide and twist. And when we got to these ones, okay, that's a neat puzzle, try to figure out how to get that to work and make it easily manufacturable with the tooling available, kind of working within those limitations. And so it's not only a toy and a puzzle for the intended audience, it was more of a puzzle for myself as well, which really kind of got me going. So when going through the ideas of how to make this, I had to look at, I have this kind of tooling. I have a bunch of, ball nose bits. I have some end mill bits I can use, and maybe some dowels I can get in there. And really going from there, start looking at what are my material choices? What can I get? And from there, if we start using some, scrap hardwood or any other planks that we can get, it really starts to evolve itself to more of a durable project, something that might, last a little bit longer, something that's a bit more personalized, because you can use this to be however long you want to be. It can be 5 links long, it can be 20 links long, and you can kind of scale it to whatever you feel you want this to be towards the end, or what your capabilities are. And so it's kind of a nice way of saying, okay, this is going to be me, this is going to be my twist on the project, and it's all going to be able to fit together. And so it was very nice to be able to kind of dive deep into all the little tweaks and changes that could make this into a very respectable toy that I feel comfortable saying, hey, here you go. This is something that we can give out and be very proud of. And one of the things that we were looking at when we were designing this is kind of, the production run of it, because this is again a bit more of a lot more work, a lot more intensive in there. So it's going to be a bit more sanding in there. again, the required materials for like those dowels and the hardwood, maybe a little bit more of a endeavor to get. But again, it's a bit more of a lower production or a lower quantity item for much more of a substantial offering. But sometimes if you're trying to reach a more broader audience, we do have some other projects that we can present to you that have a different take on what productions can be in this kind of setting.
Right, and I will also mention that we'll have a longer project video that kind of follows Brian along his prototyping and fabrication of one of his kinetic snakes. We'll link to that video in the description below. Yeah, it's interesting that you took this take in creating something that was a little bit more of, right, a substantial object, and your goal was really to create something that you were ultimately proud of and something that would last for a really long time. Let's look at a few of the snapshots of kind of your workflow here. So this was kind of the dry fit of your snake ultimately, but what is interesting is from the outside, you really don't know how all of those components are actually working and how all of the parts are moving. So we can take a look at how the components were being machined. Can you explain to us why you went for this particular solution for the mechanical aspect of the snake, for the kinetic part? What was the components that you utilized and kind of the different functionalities to get that turn in the twist?
Yeah, so again, the whole thing about making something like this is how can it be as simple as possible and still be functional and effective? And so with the tooling that we had available, and the biggest boon and also limitation at the same time that we have was that we have a 1/4 inch ball nose bit readily available. If we had different sizes like a 3/8 inch, then that may change some of the dimensions on what we're looking at. But ultimately, the way that all this is be able to put together is that it's easy to make multiple of these segments. So we got one stop here, connector rod, and it just slots into each one, and you can do that as many times as you would like. And so it's a very simple yet effective way, but it's also, as you said, it's hidden from the view, so it kind of has a little bit of that surprise element that's really nice to have with children's toys, especially if you start aging the toys down, like you get the 4 to 6 year olds. The whole idea of, oh, this does something, but how? And so it kind of gets their mind tweaking, like, go around, oh, there's something surprising about this, not on the surface. And that's what I kind of really like about this, because it's nice and clean, but it still has something interactive with them, and it's exploratory from that point. And again, keeping things as simple as possible. We can do all kinds of crazy things with magnets and going on with gears and teeth and cogs and like that, but that just adds complexity. And for something like this, simple is king.
Yeah. Do you want to walk us through your Vectric file here so we can kind of point out a few of the special tips or strategies you utilize that was particularly beneficial in this project, whether it was placement of tabs for the hardwood or lead-ins? Go ahead and walk us through that.
Of course. I mean, some of the little kind of like nitty-gritty bits about how this came together was that, and with the tabs, it's always easiest, at least for me and the tool that I have, to have any sort of tabs on any kind of flat surfaces. Just that way it's much easier to get those nice and sheared off nice and cleanly. And so for all the body segments, you'll see that how they're kind of oriented in that way to make sure that, much easier to remove, it's easier to process, they can go out. And with these body segments, there's also locator tabs on each one of them. So that way it makes alignment of them when doing the final assembly really easy. You just put in a couple dowels in those two holes, sandwich them together, and then the part is essentially done. There's no jig needed, no lineup. It's already done for you, which I think is one of the biggest benefits of doing any kind of project on a CNC device. And being able to kind of, scale how many segments you want. You can just duplicate this segment, just go boom, 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 boom. And then that's however long your essentially final product's going to be. One very kind of like key bit about when programming this, because a ball nose was used for a lot of these. So like this little line that we have here, that's essentially the cavity where the dowel goes in to add the links in together. One thing that we had to be cognizant of is that it's not an end mill. It's not squared off at the bottom. So we need to make sure that we can make clean cuts all the way through. So these cuts are actually overcutting a little bit. They go beyond their intended area to ensure that we do get a full clean cut. There's no extra interferences that we don't worry about. And so little things like that are really is where you take the limitations of your tooling and then turn them into solutions.
Beautifully said. The instinct might be to end this line here where this exterior profile is, but if you did, you'll have this radius right here, which you would have to clean up later, which means adding more time. When it takes the machine hardly any more time to cut an eighth of an inch, quarter inch farther out, and making sure to integrate that into the tool paths themselves, really, right, will save you a lot of time. And that's why prototyping this would really help you find those mistakes before you go into production, right?
Yeah, doing any kind of like little tweaks like this and seeing what works and what doesn't early and often is usually how you end up with a better final result.
Yeah, Cory, do you have any pro tips about how things you like to think about when prototyping new designs?
Yeah, CNC machines are very accurate. One thing I like to think about when we talk about some of these dowels and space, if you have two things coming together with the same exact vector with no offset, sometimes things won't fit. And so accounting for a little bit of room for glue or a little bit of room so there is a press fit and you're not actually straining the material where you might get stress fractures along the grain is something that I'm sure Brian considered and went through a couple different iterations on as he went through the prototyping phase.
All right, so I made a completely different type of project than Brian, and I think I actually may have chosen this path as a way to contrast Brian's approach to making something that was incredibly beautiful and long-lasting, but slightly more difficult to create in a production run. And I took my project design in a kind of a simpler approach, which perhaps means that it might not be something that is quite as special, but it is something you can create in larger quantities, especially if you're trying, depending on what your goals are, right? So if your goal is to create a beautiful, unique heirloom toy, being able to make 10 of those, I mean, that is incredibly special. So all of the designs that I kind of came up with were one part designs, which meant a lot less cleanup versus, perhaps having 10 parts to assemble and clean up individually into one final product. So I think just to kind of contrast, having two different projects that really are completely different and what you might consider in the approaches there. So the project that I chose, I came up with a few different design ideas for this. So for my project design, I was really interested in these kind of wooden yarn or cord design toys that were kind of interactive. It was really something that might help with dexterity and developing dexterity. I was also interested in how do you take something like this and make it accessible for a wider range of ages. So I really liked this fish design. You can go make crisscross or a striped fish, So I thought that was kind of an interesting version. I found this leaf version, this really cute sheep. I just loved this. So I thought that, perhaps if you make this out of hardwood, it could still be kind of an heirloom type of toy where it could be handed down and last a long time. Because it's so simple, perhaps it isn't as interesting to the child as long as, this mechanical, kinetic, interactive snake, but it still is something that you could hand down. And it is simpler kind of to fabricate. I also kind of came up with a alternative for older ages. So something that was more like a project perhaps than a toy with these rainbow projects that you wrap the thread around. It comes with a little wooden shuttle that you can wrap the embroidery floss around and then wrap the bows. This was a really interesting one for me because I originally started with a much larger design and had to bring it down to make it a lot easier to fabricate in large quantities, which was my goal. So I revised the design significantly and completely started back from scratch because my original design wasn't meeting my goals. So to review, I wanted to go for a simple one-part design that was easy to produce in larger batches, having some aesthetic variations where we could include the leaf design or the bear or the rainbow, kind of giving some options there, as well as, having it be an experience, a project that was interactive, and kind of give them something to focus on specifically for that time. So the limitations I ended up going with was using plywood for the rainbow project, as that was much easier to fabricate a batch good out of rather than hardwood. Because of the single part design for the bear and the leaf, that was not as complicated to make a production batch out of either, but you still have to have that material milled to the right thickness so that the yarn can pass through it. So there's lots of things to consider there. The one part design meant less CNC time, less sanding time, and no assembly at the end, and larger production. Okay, so this is my original design for the rainbow project. Here's the original prototype, which I tried to do during a meeting and then quickly found that this was going to take me a very long time to wrap. So perhaps it was going to take me quite a long time to accomplish this project. Kids might lose interest in it fairly quickly. I have a couple different versions here that I made when learning different things about how the toolpaths were actually going to work. So first here in this one, these larger bows really had a lot of flex to them. So when one toolpath finished cutting and then this next one, these ones flexed, which caused a ton of tear out and chip out later on. So these larger bows had a lot less structure than the smaller ones. The smaller one I can barely bend, and the top ones I can bend quite a bit. So the flex in that actually caused a problem when producing and cutting the actual part. So then I went ahead and tried to make one with tabs all in the middle to tie the bows together. This meant that there was a lot less tear out, but then the problem was that I had to clean up a tab that was inside between every bow, which was also not ideal. So I ended up solving a lot of problems by switching from this kind of larger rainbow design, which here I can show the full tool paths. This material is about 12 by 12 inches, which meant that this rainbow was originally about 9 by 9.5 inches, so fairly large. And then switching to a smaller design here, where I was not as limited by the flex of a larger bow. I could produce a larger batch of them nested together on a sheet of plywood, and it would really serve the purpose. The child would be able to complete the project, and maybe it would be able to hold their attention for longer. So making some adjustments based on the pocket here and the profile toolpath, I really considered tab placement is important. Do I need tabs on between the bows here if there's not any drop material between the bows? And refining those toolpaths, cutting them a couple different times, figuring out what was working and what wasn't working, really can help you later on come to a final product that's going to match your goals far better.
Well, speaking of goals, Sami, our big goal with today's conversation is to encourage everyone to try to contribute to their communities with ways that they know how. And so if you have a CNC and you're interested in using any of our projects or Vectric's projects or designing your own projects to use with a CNC, we'd love to see and hear all about what you're doing. And if you don't have a CNC, we'd love to see what you can make without a CNC, and you can still contribute to these goals. It might not be as easy to scale that manufacturing process, but again, we want to just encourage everyone to contribute to their communities however they see fit.
Right, and we were also able to cut a few of Vectric's designs. So if you are interested, be sure to check out their designs, which Vectric has made videos for every one of these projects, and we will link to those below. And they talk through how their machining approach is, how their material setup is, and that sort of thing. We hope that this has been helpful in terms of helping you think about next time you try to design your own product based on how we approach our kind of production workflows as well. So we were able to have some of our team members cut a few of the Vectric projects, so we'll share that with you now. Thanks y'all so much for joining us. We can't wait to see what you make, and we'll see you in the shop really soon. Be sure to check out those links, and if you have any questions, feel free to send us an email at support@avidcnc.com, and we'll be happy to help give some feedback or support there.
Thanks, everyone.
Happy holidays!
Happy holidays.